And in this lecture, I'm going to talk about management of acid mine drainage or wastewater. So from coal mining, wastewater is also generated either from the mine itself, because water seeps and it goes to the mine, particularly underground mine, and then that water is pumped out. And another way wastewater is generated when we are washing the coal. You know that coal contains impurities. In order to remove those impurities, coal is crushed, made into fine granules, and then it is washed in order to remove the pyrite or sulfur. So all these wastewater is treated and then released into the nearby stream, and this way we are minimizing the pollution. But I will focus in detail about the acid mine drainage. And acid mine drainage actually refers to acidic seepage or acidic water discharge originating from active and abandoned mines, coal mines, and open dumps of coal and overburden. So this acid mine drainage is generated or formed either in active mines where mining is going on, or in mines which are closed, or from the coal dumps, or from the overburden. The main cause of acid mine drainage or acidic seepage is the presence of pyrite in coal as well as overlying rocks. So acid mine drainage is a dark colored liquid which has very low pH, and pH sometimes goes as low as 2.5 or 3. Then it has high electrical conductivity and high concentration of a variety of ions and metals. The acid mine drainage has usually high concentration of sulfate and dissolved metals like iron, aluminium, arsenic, calcium, cadmium, cobalt, chromium, copper, potassium, magnesium, manganese, sodium, nickel, lead, and zinc. So all these impurities are present, all these contaminants are present in acidic seepage. So acid mine drainage is one of the biggest environmental problem, and it is the problem of mostly water and soil. Because wherever acid mine drainage goes, whether it's a river or a stream, it makes water bodies acidic. And if it goes to the soil also becomes acidic. Acid mine drainage is formed by sulfur containing minerals such as pyrite on coming in contact with water and air. And these include the sulfur containing minerals include sulfides and sulfates, and main sulfur containing mineral is pyrite, that is FeS2. And when these sulfur containing minerals, they oxidize in presence of air and water, then acid mine drainage is formed, which is highly acidic and contaminated with different types of ions and elements. If you see the formation of acid mine drainage, as I said, that it is formed by oxidation of pyrite, and the chemical reaction takes place stepwise. On exposure to oxygen and water, pyrite first oxidizes, and then it forms ferrous ions, sulfate ions, and hydrogen ions. And hydrogen ions are responsible for acidity. The produced ferrous ion then react with oxygen and forms ferric ions. So both ferrous and ferric ions are present in acid mine drainage. The reaction can be facilitated by sulfur oxidizing bacteria. So this oxidation reaction is facilitated or catalyzed by sulfur oxidizing bacteria, and the produced Ferric further oxidizes pyrite to form ferrous, sulfate ions, and hydrogen ions. So once ferric ion is formed, it triggers the oxidation of pyrite and again forms ferrous, sulfate, and hydrogen ions. So this way, if pH is very low of AMD, then ferric ions also act as oxidizing agent. At pH between 3.5 and 4, ferric ions in water are converted into iron hydroxide, which is yellowish orange precipitate found floating in water or gets deposited on the bottom. So ferric ions precipitates and forms iron hydroxide, which is yellow color precipitate, and either it is found floating or at the bottom of the water bodies. The iron oxidizing bacteria such as Acidithiobacillus ferrooxidans and other species act as catalyst and influence the rate of chemical reaction. So there are several species of bacteria like Thiobacillus ferrooxidans, Leptospirillum ferrooxidans, Sulfolobus acidocaldoreus, Gallionella ferruginea. All these are the bacteria species which are found in acid mine drainage or nearby, and they catalyze the oxidation reaction of pyrite. In a complete oxidation reaction, 4 moles of pyrite, 15 moles of oxygen, and 14 moles of water produce 4 moles of ferric hydroxide, 8 ions of sulfate, and 16 ions of hydrogen, and then it generates 1419 kilojoules of heat energy at 25 degrees Celsius. So here is the pyrite, 4 moles, reacts with 15 moles of oxygen and 14 moles of water, and then it generates 4 moles of iron hydroxide, 8 ions of sulfate, 16 ions of hydrogen, and then energy. In the oxidation reaction, solid pyrite, oxygen, and water. Pyrite, oxygen, and water are the reactants, and solid ferric hydroxide or iron hydroxide, iron ions, ferrous and ferric, sulfate ions, and hydrogen ions, they are the product. And along with these products, energy is also generated. If you see an stream contaminated with acid mine drainage, you can see such type of color. And in this case, you can see that precipitate is settled at the bottom. And in this case, here it is floating on the surface of the water. Here is the chemical reaction summarized. So chemical reactions takes place stepwise in 4 steps. First, pyrite reacts with water and oxygen, forms ferrous ions, sulfate, and hydrogen. Then ferrous oxidizes and forms ferric, Fe3. And again, this ferric ion oxidizes pyrite, and then it forms ferric ions, forms iron hydroxide, which is a precipitate, which gives the yellowish or orangish color. So 4 chemical reactions take place side by side in the formation of acid mine drainage. Then other factors like mineral reactivity, the size of the mineral or coal particles, the availability of oxygen and water. If readily available oxygen and water is there, then chemical reaction will be faster. Then oxidant sulfide oxidation means ferric. If ferric ions are present, then also chemical reaction is fast. pH condition also determines the chemical reaction rate. And finally, the bacterial activity. So all these factors, mineral size or reactivity, availability of oxygen and water, oxidant like ferric ions, pH condition and bacterial activity are responsible about the rate of the chemical reaction. You can see a stream which is affected by acid mine drainage. It looks, this water is appearing clean, but bottom is settled with iron hydroxide, and that gives orange color. If a water body is contaminated with acid mine drainage, then pH becomes low, it becomes highly acidic, it looks colored, orange color or yellowish orange or brownish color. It has high turbidity because iron hydroxide is present. It has high conductivity because different types of elements are present in that. And then very high levels of sulfate, iron, and other toxic metals. So wherever there is contamination of water bodies with acid mine drainage, you will find this type of characteristic of water. Here you can see the streams affected by acid mine drainage in 7, whereas streams which are affected by acid mine drainage, which are contaminated by acid mine drainage, you can see pH has gone down to 2.9, 3.2, 2.9, 3.8, and so on. And this way, water becomes acidic. At the same time, you will find high concentration of sulfate. Here, in unaffected stream, it is 7.41 or 2.67, whereas in affected, it is 151, 113, 161, and so on. So this way, contamination of acid mine drainage affects pH, sulfate, total dissolved solids, and all other parameters, and this way quality of water deteriorates. Even you can see the parameters of acid mine drainage from different places. These three are from Korea, from different mines. This is from India, and this is from Nigeria. And everywhere you'll find the pH is very low. 2.73, 3.49, 2.51, 3.01, and 4.92. So low pH is the main characteristic of AMD. And then wherever streams are affected by acid mine drainage, you will find that all animals which live in water, they disappear because they cannot tolerate acidity. So here is the data that mayfly, stonefly, and wherever P is there, it means present. So this is a river which is not affected by acid mine drainage, and these are the rivers where you will find that most of the species have disappeared from the affected streams. And it is due to acidity and presence of toxic elements in water. The affected streams also are less diverse. You can see here diversity of macroinvertebrates. Some invertebrates live in water bodies. So here you can say different groups of macroinvertebrates are present in unaffected water body. Whereas in an affected body, only 3 groups are present. So this way diversity goes down, and the particularly fishes disappear first, and then all other fauna of the water body. Acid mine drainage affects, it has got physical effect, it gives coloration to the water, it increases the turbidity, and then the water body is deposited by precipitate of iron hydroxide. It also affects chemically, and the main is acidity, and then presence of different types of elements and ions. Then it's biological, it also affects biologically to the water bodies, and I have already talked about the diversity. The fauna disappear, or if they are present, their diversity goes down. And then ecological, if water, such type of water, acidic water goes to the land, then soil also becomes acidic. And then it has got several social impacts. For example, if rivers become devoid of fish or prawn or edible plants, then people are affected. So acid mine drainage affects the physical, chemical, biological, and ecological way, and all together affect the human beings. You can see it also affects the hydropower plants. Wherever such type of acidic water is going to a reservoir, then you will find that surrounding area is colored. And this is the photograph taken by me from Umrangso hydropower plant, which is located at the border of Assam and Meghalaya. So whatever coal mining is going on in Meghalaya is generates acid mine drainage, and same contaminated water goes to the reservoir of this hydroelectric power plant. And so it not only gives coloration to the surrounding area, to the rocks and the dam, but if you see here, this slide, it also damaging the metal parts of the power plant, pipeline and different parts are gets damaged due to acidity. I have already shown this slide in the previous lecture that if acid mine drainage goes to the soil, soil pH also goes down, and then soil fertility is affected. Then comes how we can take care of acid mine drainage. We can, because since acidity is the main problem, we can treat acidity by alkaline material. And this treatment is done either by following the active treatment method, where we are adding some alkaline chemicals in the acid mine drainage ponds, and this way we are neutralizing the acidity of the acid mine drainage. And after neutralization, the neutralized water is released into the nearby streams, and this way we are minimize the ill effect of acid mine drainage. So the most widespread method used to mitigate acidic effluent is an active treatment process involving addition of chemical neutralizing agents. Addition of an alkaline material to AMD raises the pH, accelerates the rate of chemical oxidation of ferrous ions, and causes many metals to precipitate. And this way, the impurities settle at the bottom and water becomes neutral. But this active treatment method, in active treatment method, various chemicals are used like lime or slagged lime, calcium carbonate, sodium hydroxide, and magnesium oxide or hydroxide. These active treatment methods are costly, but they are effective, because we have to buy all these chemicals and put continuously in the acid mine drainage pond, and this way it is a costly affair. But since we are adding alkaline chemical, then it is very effective. So although active chemical treatment can provide effective remediation of AMD, it has the disadvantage of high operating costs, because acid mine generates continuously, and always continuously you have to add chemical. So it is a costly affair, and in emergency we are using active treatment, otherwise we are not using. Rather, we are using passive treatment, which I will discuss. So another method of neutralizing the acidity of acid mine drainage is passive treatment, which involves passing of acid mine drainage through a wetland or a channel of naturally available alkaline material like limestone. And this way, we intend to improve the quality of water. We neutralize the acidity, and then neutralized water is released into the nearby rivers and streams. And this way, we are reducing the harmful effect of acid mine drainage. Different methods are available for in passive treatment. Aerobic wetland, we construct wetlands, and where AMD is left for few days, and by microbial reaction and plants present there, neutralization takes place. Or wetland liming, sometimes lime is also put in the wetland so that it enhances the rate of neutralization. Then we are also using open limestone channel, means we pave limestone in a channel, and then acid mine drainage is passed through those limestone paved channels. And this way, slowly, acidity is neutralized because limestone is a alkaline material which is found plenty in nature. Then aerobic wetlands. Sometimes we aerate, we put additional air in the wetland, and this way we activate aerobic bacteria and neutralization is better. And sometimes in combination we are using anoxic limestone drains where we are putting organic material so that anoxic condition is created, and in this condition anaerobic bacteria become active. So both way, in anoxic condition, we are treating the acid mine drainage. The commonly used method is open limestone channel, where acid mine drainage is passed through a limestone channel, and this way, slowly. And limestone is a cheap material, so it is a viable method and it doesn't need any much technical assistance. In the process of neutralization, actually limestone contains calcium carbonate, that is the alkaline material. It reacts with hydrogen ions and forms different products. This way, hydrogen ions are utilized and neutralization takes place. Uh, since time is limited, I'm rushing fast, and I will be talking about a case study which we have taken in Meghalaya in order to neutralize the acid mine affected streams. And just let me give the background of Meghalaya. In Meghalaya, coal is found in all different regions, in Jaintia Hills, in Khasi Hills, and Garo Hills. The mining is taking place, extensive mining is taking place in Jaintia Hills, and due to coal mining, all the streams have become acidic because continuously acid mine drainage generated from coal mines and coal storage site or from overburden is going into the nearby streams. So most of the streams have become acidic, and no organisms, particularly living organisms, are present in those. No fish, no frog, no prawn, nothing is available because water has become highly acidic. So we wanted to solve this problem, and then we took a project there. And so I will be discussing this case study. It was a big challenge to start this project because in Meghalaya, land belongs to the people. So you cannot do anything without the permission of the people. If they don't want, then you cannot do anything, any research activity. So it was a big challenge because the mining area is full of mine pits. So in Jaintia Hills alone, about 25,000 mine pits are available, are present. So in that situation, neutralization of AMD affected stream is a challenging task. So it is very difficult because if you neutralize at one place, from another place, the river becomes acidic because AMD is coming from another pit. But we have chosen a isolated stream where only few pits were present, and that stream earlier people used for their domestic uses. Water from that stream people use for domestic purposes. Then another challenge was land belongs to the people, very little control of the government. Only 7 to 8% land in Meghalaya is purchased by government. And that too all land, most of the land is in the form of protected area. Then weak mining policy of state and nexus between influential mine owners and politicians in the state. So nobody wants that any such type of eco restoration work should be done because they think that their mining will be affected. And in Meghalaya, no EIA is required to do mining because land belongs to the people and people are doing mining at their will. So we started this project by creating awareness and by making people sensitive to the environment, ecology, and water, and about the value of agriculture and future food security. So we conducted meetings with the villagers, and here you can see the meeting was done indoor and then outdoor, and we focused on the environmental problems and how these environmental problems are affecting the people. So consultation was done and then awareness was created and we sensitized people that, and then planning was done. And then we mobilized the community, we involved the community because we thought that if it is done in isolation, probably project will not be successful. So we involved people in construction and rather money was transferred to the people. And people became interested to utilize the AMD affected stream because earlier they were using the water of that stream. So they were also aware that the water has been polluted, it has become acidic, and that's why they are not using. So they thought that if improvement takes place, then they can use that water and it will be beneficial for them. So in this, it was situated in Jaintia Hills, and this is the location of the project site. And here we chose two streams. In Jaintia Hills, stream A and stream B we have named, and both they joined and then formed another stream, and from here people used to take the water. So first we selected the streams where very few, you can see here the photograph of these two streams, stream A and stream B, and this stream is joining and then water is going further. Here is the diagrammatic representation of the those streams, those two streams A and B, and it was situated in Mulawar. The name of the stream was Mulawar, and so what we did. So we constructed open limestone channel. So by dredging, we removed the whatever mud or sediments were present in the channel. We made it flattened. We flattened the channel, and then we put limestone in that channel. You can see these boulders are limestone boulders, and here earlier streams were like that, zigzag, and depth was irregular. So it was made straightened, and we removed the mud from the bottom, and it was made like this. You can see, and then we put limestone in this stream, and in between we made the gabium check dam so that limestone cannot slide Otherwise, with the force of the water, limestone can go down, and that's why Gabion check dams were constructed in between. And here you can see in diagram that these are the Gabion check dams in order to stop the sliding of limestone to the at the downstream. See, in the beginning, the activities started like that flattening of the channel and then put limestone in that. And then you can see a finely constructed open limestone channel. Why it is called open limestone channel? Because it is not covered with anything. It always remains in contact with the atmosphere. So this way, oxic condition, it works in oxic condition, and that's why it is called open limestone channel. You can see another view. This is the picture of the Gabion check dam covered with wire mesh, and this is the open limestone channel constructed. You can see here also, these are the Gabion check dams in between, and then limestone pieces were laid at the bottom of the channel. Here again. Now, here is the data of, so the length of the two streams were different, and we put different amount of limestone. So you can see here, before treatment, what was the pH, and after treatment, what became the pH. So in stream A, before treatment, pH was 4.31. And after treatment, it became 6.57. So there is a drastic improvement. The pH of water increased near to neutral. And not only this, other parameters also improved. Same thing happened in stream B. Here, earlier pH was 4.9. And then after treatment, pH became 6.32. So there is an improvement of 1.83 unit. And in this case, the difference is 2.26. So the open limestone channel, which we constructed on the streams in the village of Jaintia Hills, we found that it is working satisfactorily and good result is yielding. So we extended this work to other streams also. And this time, with the help of the different agencies, even government of Meghalaya was also interested, and some funding from other agencies also came. So such type of activities were taken in many streams where streams were affected by acid mine drainage. You can see here the water is coming from the neutralized water, and then we constructed a small reservoir. So water was collecting here, and after few months, 2-3 months, some animals also appears, two species of fish, some insects, because since water became neutral, so slowly the fauna also appeared in this, and pH of water was around continuously around more than 6.5, and that is the average value in Meghalaya. And getting encouraged by this improvement in quality of water, then villages wanted that they should take this water to their village, which was about half a kilometer away. And from different agencies, they requested fund, and they let down the pipeline from this reservoir to their village. and now they are using this treated water for their domestic purposes. So different agencies, different people were involved in this, and so this way, if you treat acid mine drainage contaminated streams with open limestone channel, then we can improve the quality of water. And one thing more, that it is a very cost effective method. The limestone is a very cheap mineral, particularly in Meghalaya. It is available side by side. Wherever coal is present, nearby you will find deposits of limestones are also present. So it is cheaply available, readily available, and one can use this limestone very easily. They can procure and use to neutralize acid mine drainage affected streams. This study is published in American Journal Mine Water and the Environment, and it is available online also. So if anybody is interested, one can go through it, and if such problems are there, they can apply this method, constructing open limestone channel to neutralize acid mine drainage wherever it is required. Since I lost time, so previous slide I skipped, and then we finished quickly. So, and then I wanted to give at least 15 minutes time for interaction. So now I am finishing this lecture, and if anybody want to discuss or want to know, then I welcome them to ask questions or to interact. Thank you.
Thank you, sir. Participants are requested to communicate with our resource person. There is a question from Abu Libda. Are there any equivalent of limestone?
Then you can use the lime, because what happens that wherever lime is also manufactured from limestone, but lime is little costly. So since limestone is easily available, people are using readily, but some other materials have also been used, but they are less effective. For example, fly ash, which is easily available near thermal power plants, because when we burn coal, then a lot of ash is generated, and disposal of ash is a big problem. So ash is also a little bit alkaline, and since it is easily available, so people have used fly ash or the ash from coal thermal power plants, and that is also working, but it is not as effective as limestone, because its alkalinity is very low. That's why it is not very effective. Okay.
Okay. Is there any question from participants? You can unmute yourself also. Participants are requested to unmute if they have any query.
Sir, my name is Ajay. So that slide number 39, can you explain little bit once more, please?
39.
Yes.
This one?
Yes, sir.
Yeah.
Thank you, sir.
You wanted to see something from?
Yes, actually, can you explain this again? One more, sir. Actually, you have told that stone, how to use stone for the water segregation. I think it's not on the, it's 37 slide.
37.
You have explained wonderfully that thing that I know.
This one.
Not or more upper side, sir.
Okay.
Yes, yes, this one.
This one.
Yes, sir. So actually, yeah, can you explain this more?
Okay.
Yes.
So actually, this was earlier. This was a stream like this here. You
Right.
can see it was a
Yes,
zigzag
yes.
stream,
Right.
and through this stream, acidic water was flowing
Hmm.
because nearby coal mining areas are were there. For example, here you can see, if you see carefully, there is one pit is present,
Right.
and so acid mine generated from this pit. If it goes here in this, so water becomes acidic, and this was the situation. In another stream also nearby, some pits were there which were generating acid mine drainage and going in this.
Right.
So what we did the dredging. We removed the mud from the bottom
Uh-huh.
and made uh, the bottom flatten, we,
Uh-huh. Okay.
so that we can lay down the limestone pieces.
Uh,
So we got limestone from the nearby area. It
hmm.
was broken into pieces and then let down in this stream. So you can see here in this. So these are the limestone pieces.
Right. Right.
So 3-4 layers of limestone was put in this stream.
Hmm.
And since when water flows, limestone, there is every chance that limestone pieces will move downward.
Right. Right.
So in order to check, in between, we made this Gabion check dam.
Oh.
So you can see here clearly
Okay.
that little elevation,
Yes. Yes.
and this is also filled with limestone, but covered with uh,
Right. The buyer.
iron
The
mesh,
buyer.
so that it remains at this at the place.
Great
So
idea.
so what happens if you lay down like this,
Hmm.
and water is coming from here?
Right.
So acidic water reacts with limestone because
Hmm.
calcium carbonate is present here in
Hmm.
limestone,
Hmm.
and slowly it gets neutralized. So suppose pH is 4.3 here. So
Huh.
if you measure the pH here, it will be 5. If you go further down, you will find 6. And if you go further down, it will be 6.5 and so.
Oh, oh, oh.
All depends on the amount of limestone which you have put in the channel. And it
Okay.
also depends on the amount of water which is coming in this channel. If more acidic water is coming, then it
Hmm.
will not be effective. It will be neutralized, but not uh, to the
Hmm.
level which we want. So we control the flow of water,
Hmm.
as well as we also manipulated the amount of limestone which we put there. So by standardizing, we reached to a situation where we were able to raise the pH to 6.6 or even more. And this way,
Hmm.
neutralization takes place.
Great idea, sir. It's very interesting.
So whether I am able to explain what you
Yes,
wanted
sir.
to
Yes.
know?
Very wonderfully. Thank you so much, sir.
Thank
Do
you,
you
Dr.
get it?
Ozam, for your query. Is there any more questions? You can unmute yourself for any query. Participants may unmute themselves. Query.
Sir, I have a small question again, whether
Yeah.
I don't know whether it is relevant or not.
Mhm.
So suppose if this is really interesting ideas and everything which local people don't know, okay, and even there is no books and education available.
Mhm.
So suppose if some organization, charity organization, NGO kind of team
Mhm.
can want to work for this all the things in any villages where the water supplies problems are there or something are there, So is there any government project or governments are working this kind of thing where they help the organization or NGOs on same thing?
Yeah, actually, this in 2014,
Hmm.
this the coal mining in Meghalaya was
Hmm.
stopped
Yes.
because uh, people from Assam, the Masa area, went to the National Green Tribunal,
Right.
and then when National Green Tribunal heard the case, they found that all coal mining is going on illegally. They don't take any permission, anything. So after 2014, the area became a matter of focus for the NGOs, for the different funding agencies,
Hmm.
for the National Green Tribunal, as well as Government of Meghalaya.
Hmm.
So some NGOs, they started some work, or they were interested
Right.
to do some work,
Hmm.
and they took our help also. So, and even government agencies, Government of Meghalaya's different departments, they also, like Soil and Water Conservation Department of Meghalaya, they also were interested to do such type of activity. But
Hmm.
then what happens that 2 years ago, NGT permitted and NGT allowed Government of Meghalaya to grant permission for coal mining. And
Okay.
now Government of Meghalaya is the agency which can permit coal mining.
Hmm.
So on paper, coal mining is banned, no coal mining is happening. But in last, after 2014, coal mining never stopped. It
Oh,
is going on because
illegal.
it is in hand very powerful, influential people. Some politicians are also involved. So
Oh.
in this situation,
Hmm.
when coal mining is going on, the NGOs which were interested to work, they got discouraged. And nowadays, again, no NGO is working in this area. Reason is, if you cannot stop the source of pollution,
Right.
then what is the means fun of resolving the problem? So first, source should be stopped. That is not
Hmm.
happening, and that's why I find, because always agencies are in contact with me, so I find that
Hmm.
very little interest is there of agencies to do some work.
Yes, yes, yes. Yes, great. Explain this thing. It's very interesting to me because I work this kind of things in not in Meghalaya but in MP.
Okay.
It's a very useful information for me.
Okay, such means in other countries like United States or other Europe, some European countries, Germany, such type of neutralization activities have been taken place. They have adopted,
Yes,
but in India, I don't think we did not find anywhere that anything, any coal mining agency is doing to neutralize the acid mine drainage. In Meghalaya, since mines are spread all over the district, particularly
yes.
Jaintia Hills.
Hmm.
So most of the water has become acidic and people are the sufferer. And sometimes you will find that they have very big house, nice interior, sofa, everything, but they are fetching their drinking water from a distance of 10 kilometers by their vehicle.
Oh,
So this is the situation here. For rich people, there is no problem. They can even drink bottled
right.
water.
And they
But
purchase
problem is
from
with the
somewhere.
people,
Yeah.
with the poor people,
Hmm.
and
Hmm,
they
hmm.
are using same water for their domestic use as well as for drinking also.
Oh,
And long-term effect on their health, nobody has studied what will happen.
right, right, right.
Yeah,
Perfect. Thank you for explaining wonderfully, sir. Thank you so much.
thank you. Any other question from?
Any more questions from participants? think, sir, there are no more questions.
Yeah, at the end, one thing I would like that I'm very sorry that 1 hour we lost due to technical problem, and I have to hurry up and finish this lecture because everybody means this is the last lecture, so and 5 o'clock, so everybody were in the mood to leave. So, but I have given a gist, a summary of the liquid waste which is generated in coal mining area and how we can take care of this. And finally, I thank all the participants as well as the organizers, particularly Dr. Neog and his colleagues for giving me this chance to share some of my experiences. Thank you very much.
Welcome, sir. We, in fact, are very grateful to you for uh, extending your cooperation throughout the program. And today itself, in spite of hurdles we have faced, ultimately we could restore the or fix the issue, and you have so nicely presented and uh, and has offered us a very informative and engaging session. And thank you for that, sir. Thank you for sharing your experience and knowledge about the management of neutralizing the effect of acid mine drainage, both active as well as passive methods, and for sharing some of the case studies you involved in the site of Meghalaya, where acid mine drainage is a very common phenomenon. We have been greatly benefited listening to your lecture, and we are grateful also for gracing us in this FDP. I'm in fact running short of words to express my appreciation for your enormous support in conducting this FDP. Thank you, sir. Thank you very much.
Thank you. Thank you. So I'm leaving the meeting.
Yes, sir. Thank you, sir.
Okay. Thank you.
Thank you, sir.